So, for example, for difference of squares, it's really easy to use if you know your perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 6, 9, 4 squared is 16, 5 squared is 25, and so on. But if you don't know your perfect squares, it could be tricky. So here's how it works. It has to be a minus sign between two perfect squared terms. So in this case, to get x squared, I would have to multiply x times x. To get 25, I would have to multiply 5 times 5. And there has to be a minus in the middle. That's what's called difference. So this would factor out to be x plus 5, x minus 5. The reason for that is because they have different signs. When you multiply them together, you get x squared plus 5x minus 5x, and then the negative 25. So these have opposite signs, and they will always cancel out. And you're left with the two terms on the edges. So anytime that your first term and your last term are perfect squares and there's a minus between them, you can do this method. So if you have a different perfect square, like 9 and 16, the square root of 9 is 3, the square root of 16 is 4, and there's a minus between them, so we can do 3 and 4. Just make sure one of them is positive, the other one is negative, and there's your answer. But those are the rules. They both have to be perfect squares. That means you can take the square root of them nicely, and there's a minus between them. Otherwise, you're going to get a mess. So if I had 164, the square root of 100 is 10, the square root of 64 is 8, and you can do the negative first and then the positive, but there's your answer. Factoring is super fast when you have that method of difference of squares, but it will not work if there's a plus sign or if one of them is not a perfect square. But what you can do, if possible, is try to divide them to see if they have a GCF. So for example, if I have 32 x squared plus 8, not plus 8, it has to be a minus. You're like, well, 8 is not a perfect square, 32 is not a perfect square, but they both have a GCF of 2. So if I divide them, I get 16x squared minus 4, and now these work. So the square root of 16 is 4, and the square root of 4 is 2. Close. And then, I don't know if you noticed, but notice this is 4 and 2. They're both even, so they still have a GCF. So it looks like we didn't take the biggest GCF that they had in common. So let's go back and fix that. 32x squared and negative 8, they're both divisible by 8. That's the biggest GCF they have in common. So when I divide by 8, I end up with 4x squared minus 1. And this is 2 times 2, and this is 1 times 1. So now I can do difference of squares. And there's my answer. This one was incorrect just because you still had a GCF to factor out, a greatest common factor of a 2. And you have to divide out of all of these. So take out a 2 from here and a 2 from here. And you would have to, to multiply them with this 2 to get an 8. So if you don't take the greatest common factor first, your answer would be wrong. This is the most factor form. This is factor completely. This is not factor completely. So be careful. Always take out the GCF first.